Okay, everybody, today let's look at this question asked by one of my students. Aluminium sulfate, right, decomposes upon heating, forming aluminium oxide, sulfur dioxide, and oxygen gas. Okay, so the first thing you want to do is to write a balance equation. In fact, that's what the question asks us to do. Number one, write a balance equation with state symbols for the decomposition. So I've already done that. Okay, the second thing, right, we need to determine the percentage purity of the sample, assuming impurities remain inert. So the impurities didn't react. All right, let's take a look at all the information given. We have 150 gram of sample, right, of this impure sulfate. It was heated until the sample reached a constant mass of 83.6. Okay, so when I first looked at the question, right, I had thought that 83.6 gram was the aluminium oxide. But this is not the case because earlier on, right, we are told that the impurities remain inert. So they actually did not react and therefore are still present in the 86.3. Okay, so I think one way to actually understand this better is to actually draw a bar chart. Okay, so you have the 150 grams. Okay, this 150 grams is aluminium sulfate, Al2SO4 3, okay, plus impurities. Okay, so there's these two things that are present in the 150. Okay, let's just highlight it. And then after heating, right, after heating, some parts of it were actually driven off. Okay, so you're left with 83.6 grams of aluminium 2O3 and the impurities. Okay, so because we do not know how much is the impurities, we cannot conclude what is the mass of aluminium oxide. Okay, because there is impurities, they are still present. Okay, they have been leftovers from the heating. Okay, so what we can do, right, we can take 150 minus off the 83.6. Okay, that will give you about 64.4 grams. This 64.4 grams, right, has to be equated to the 3 moles of sulfur dioxide and the 1.5 moles of oxygen. Okay, so you're gonna take just this mass, all right, equate it to both of these gases. So how do you go about calculating, doing this calculation, right? Let me just erase off the diagram. Please jot down the diagram so that you have an impression, right? Okay, so one way that you can solve this question, right, is actually to equate 3x, let x be the number of moles of sulfur dioxide and also number of moles of oxygen. Okay, so 3 times the number of moles of sulfur dioxide, 3 times sulfur is like 32.1, this is the AR, plus 32 plus 3 over 2 x, okay, number of moles of oxygen. Okay, equate that to 64.4 grams. Okay, so what we've done, right, is we have equate the mass, okay, the mass that it decreased by, right, with these two gases. Okay, because these two gases, there are no impurities, right? The 64.4 is basically just these two gases. And remember, right, the gases, their volume ratio equals to their mole ratio. Okay, so all you need to do is to convert the number of moles to mass, and that will be actually equals to your 64.4. So you actually need to just solve for X, you will get the number or moles of each of the gases, right? So once you get the number or moles of the gases, you can actually use this number of moles. This number of moles will be the number or moles of your aluminum oxide. Okay, so once you get a number of moles, actual number of moles of aluminum oxide, you can calculate obviously the number of moles of aluminum sulfate, and thereby calculating the percentage purity. Okay, so this question, you actually need to focus on the mass loss as the mass of the gases. All right, I think this part will be the most challenging part, which is to equate the mass of each gas using number of moles times the MR of the gas. Okay, so I hope you got a good overview of how to solve this kind of questions.